Hello my people, I hope we're doing well. This is the second video in which I'm working an old test from years gone by. This one was a test I gave my honors pre-calc kids in 2011-2012. This is actually the second page with material on it because in that test I actually gave them a unit circle to fill in. I figured I would not waste time in this video attending to that, but I thought we'd go ahead and just jump right in. Now, obviously, I failed to do an edit again here. Shows you that writing tests, I basically open up the document and basically save as to make the next year's test oftentimes. Okay, it says determine two coterminal angles, one positive and one negative, for the given angle. Be sure that your answer is given in the same units in which the problem was posed, radians to radians, degrees to degrees. Now, as I said before, when we are dealing with coterminals, you need to add 2 pi and then subtract 2 pi. Add 360 and then subtract 360. So basically you need to add 2 pi here, but you need to add it in a way that is helpful, meaning sort of unreduced into 8 pi over 4. Okay? And that leaves us with 5 pi over 4. But we also need to subtract 8 pi over 4 to get our negative coterminal, which is a negative 11 pi over 4. Now that one was pretty easy because it's a unit circle value and it's really familiar, and you should be able to visualize negative 3 pi over 4, and it should confirm in your mind's eye that it is coterminal with 5 pi over 4, right? And for those of you who are not quite as visual as some of your colleagues, what I mean is negative 3 pi over 4 is over here. 5 pi over 4 is that. And then negative 11 pi over 4 is that. Okay? And so they all start at this positive x-axis and all terminate right here. Like I said, the thing is that those angles are not equal, but they have the same trig ratios, and that's the benefit of it, okay? Now, 7 pi over 18, we need to do something similar. We need to add 2 pi, but we need to add it in the form of 36 pi over 18, which is, a little bit more ugly than, 8 pi over 4, but not terribly. And then we also need to subtract 36 pi over 18. Now, this one should be 43 pi over 18. That's fun. And this one ought to be negative 29 pi over 18. And those are our two coterminals. When we get down to degrees, we need to be adding 360 and subtracting 360. And so and the great thing about that is you don't have to do it in another form, right? In order to get ahead of the game in terms of common denominators, it winds up being just really straightforward. You add 360 and then you subtract 360. Now 230 plus 360 is going to be 590 degrees, and of course when you subtract it's negative 130. When you do this, it winds up being 320 degrees on the positive and negative 400 degrees on the negative. Now, that's pure procedure. There's really not, it's not really, hugely, deep and complicated and fabric of the universe to make you scratch your head and give that quizzical look. But it's important that we sort of go through this and we become so familiar with these things that they become second nature so that we can then build the more complicated trigonometric concepts on top of that, okay? It's kind of like just simple arithmetic. Arithmetic is not math. Number sense is not math. But you can't understand a lot of what goes on in mathematics unless number sense is part of the foundation. And that's kind of what we're doing here, okay? Now, these instructions are the same as the test in the last video. Find, if possible, the complement and supplement for the given angle. Be sure your answer is given in the same units in which the problem was posed, okay? Now, 2 pi over 3, just like in the last test, we had a radian measurement that was greater than pi over 2. And this is greater than pi over 2. Remember, pi over 2 is equivalent to 90 degrees. This is equivalent to 120 degrees. There is no complement that is possible, but I know that my supplement needs to be pi over 3 because 2 pi over 3 and pi added to pi over 3 gives me 3 pi over 3, or just pi, okay? Now, this one right here, we have another odd denominator, okay? So it might actually be a benefit to get to there, because what we need in terms of a complement is we need something that is going to give us 9 pi over 18. 9 pi over 18 is what we're looking for, and of course that means I'm going to add 5 pi over 18. The supplement's a little bit easier because you have 2 pi over 9. You need 9 pi over 9, so you add to it 7 pi over 9. Now, again, we have down here degree measurements, and the degree measurements, partially because you're much more familiar with them, secondly because you don't have to deal with changing denominators and stuff like that in order to get the sum that you're looking for. 73 degrees simply needs 17 more degrees in order to make 90, and needs 107 degrees in order to make 180. 20 degrees needs 70 degrees to make 90, and it needs 160 degrees in order to make 180. So those are the complement and the supplement. Now, just like the last one, we're going to follow that up with doing some conversions from radians to degrees, and then from degrees to radians. And remember, our two ratios are either pi over 180 degrees or 180 degrees over pi. And which one do we choose? Well, we choose the one that's going to get rid of what we want to get rid of, right? And so we will put here, since I know that the pi needs to go away, we're going to put the pi on the bottom for these two at the top. And we're going to multiply both of them by 180 degrees over pi. The pi's, of course, are going to cancel out. This 9 and this 180 obviously have a common factor of 9. 9, 20, and so that winds up being 40 degrees. Okay? Okay, let me change the lighting on this. I think that'll help it from going dark all the time. Okay, now we have 5 pi over 4. We've crossed out the pi's because we're multiplying it by 180. Now 4 definitely goes into 180. We saw that in the last one, and I wind up with 45 degrees. 5 times 45 degrees, you can actually just think about that in terms of the unit circle. Just sort of visualize it going across. 45, 90, 135, 180, and then dipping down into the third quadrant into 225. Or you can just do the arithmetic. 5 times 40 is 200. 5 times 5 is 25. Add them together. Now, I probably did this on accident, but looky here. We know, obviously, the answer to this one. That's going to be pretty easy. I probably got these tests back, saw that on all the answers, and started kicking myself, but whatever. Let's go ahead and actually do the work here on number 11. I see negative 150. I see down here 180. I know that they have a common factor of 30. So, and here's the thing, when you cross out something and you have the negative right there, I wouldn't assume that when you go back to this you're going to remember that negative. I would bring the negative along with when you're noting what's left over, okay? And so that becomes negative 5, and that becomes 6. So we get negative 5 pi over 6, okay? Part of being a successful math student is just being self-aware, okay? Knowing what it is that trips you up, and taking steps to prevent that by either, clever notation or whatever, okay? Now, 13 is way too similar to the multiple choice one that we had on the last test, and this one's a latitude one. So let's go ahead and sort of skip over these two. We have another set of multiple choice questions, and we will go ahead and walk through those. Now, obviously, 15 is an exact duplicate of what we had in the last one. The word radian is abbreviation for, well, I've changed up the A, B, C, and D, but it's radius angle. It's D down here. The given angle has what reference angle? Okay, well, remember that when you're dealing with reference angles, you're talking about the angle that it makes with the nearest x-axis. 120 degrees is going to be in the second quadrant. So it is going to be closest to the negative x-axis, and the negative x-axis is 180 degrees. So how far is it from 180 degrees to 120 degrees? And the answer, of course, is 60. All of the following trigonometric functions are even functions except, okay, so all, and it shouldn't be following. It's another just sort of poor choice of words as I was writing that question. All of the trigonometric functions are even except, well, the only even, so remember that the even trigonometric functions are cosine and secant. The odd trigonometric functions are sine, its reciprocal, tangent, and its reciprocal. Now, I see the fact that this is even right here, okay? This is even, and this is even right here. The rest of these are odd. And actually, that was a really poorly written question. Huh. No, actually, no, yeah, because it could be B or C in the way that it was written. So that was actually a really poorly written question. Huh, it happens. All right, identify the quadrant in which theta lies. Now here, this basically is saying that sine is negative. Now if sine is negative, okay, then that means that it is in the, okay, that's where y is negative. It's going to be in the third or the fourth quadrant. Here it says cosecant is positive. Now, before you even riddle that out, you should automatically have red flags going up in your head, because sine and cosecant are reciprocals of each other. And when you take the reciprocal of something, that does not impact the positiveness or negativeness of it. Where sine is positive, cosecant is positive. Where sine is negative, cosecant is negative. So basically this question is gibberish. And so the answer is none of the above, okay? When asked to determine the trigonometric value of an angle measurement, the answer represents which one of the following? Okay, so basically the output of a trigonometric function. Now, obviously, trig functions, the input is your theta value because it's sine of theta, cosine of theta. It's the angle measurement that goes in. What comes out is a ratio, okay? It is not arc length. It is not its relationship to other angles. That's really vague. That's not how big the corresponding triangle is, because similar triangles have similar ratio of sides. It has nothing to do with that. But it is a ratio of sides. Now, let's take a look at some of the problems from 4.3 and 4.4, some of the right triangle trig, because that gets us a little bit more, it gets us past the sort of definitional and sort of rote arithmetic aspect that is in 4.1 and 4.2, and gets us more to the nitty-gritty of the trigness of trig, right? And so here we have in number 20, the terminal side of an angle passes through the point 3, -5. Now this is actually awfully similar to the one in the last one, except it's not 3, -4, it's 3, -5. And so I think I probably, now of course this was almost a decade ago, so I can't guarantee, I would guess that I probably wrote this wondering how many people would force the 3, 4, 5 right triangle, okay? Because when a 3, 4, 5 right triangle, remember that the hypotenuse has to be the longest side. So in a 3, 4, 5, it's not a 3, 4, 5 right triangle unless the 5 is the hypotenuse. And so in this case, it's not, right? Your x value is 3. Your y value is -5. This is not 4. This can't be 4, right? So 3 squared is 9. -5 squared is 25. This over here is root 34, which is just a little shy of 6, right? Because 34 is almost 36. From there, it actually should be relatively easy to just read the ratios right off of the triangle. And we have opposite over hypotenuse, hypotenuse over opposite for cosecant. We have adjacent over hypotenuse and hypotenuse over adjacent. And then we have opposite over adjacent and adjacent over opposite for our cotangent. Now, I would, of course, rationalize these denominators if I had the room right here, but I don't because I'm writing big enough for you to see and I'm writing in pen. So let's go ahead and move on to the next one. The next one is cosine of 4/5. Now, cosine of 4/5, as you may know, you probably should know by now, is ambiguous, meaning that it doesn't have a definitive meaning because cosine can be 4/5 in 2 different quadrants. It can be 4/5 in the first quadrant because cosine is positive in the first quadrant. It can also be 4/5 in the fourth quadrant because cosine is positive in the fourth quadrant. We need another piece of information to tell us whether we're in the first or the fourth quadrant, and that's why we have that qualification of tangent theta is less than 0. Tangent is negative. Well, we know in the first quadrant everything is positive, so by default we're obviously dealing with a fourth quadrant angle. Okay. Now, the reason why Pythagorean triples show up so often is largely because teachers who write tests and instructors who write textbooks don't want their students too often to be bogged down by really difficult arithmetic and to miss a trig question based upon something that has nothing to do with the trigness of the trig question, right? They want, if you're going to, and I totally messed that up. 1, 2, 3, 4, and the thing is that it's actually, I was talking and not paying attention to what I was doing. Let me pause my lips for a second. Now the adjacent is going to be 4 units. I'm anticipating, of course, that the opposite side is going to be 3 and the hypotenuse is going to be 5 because that cosine ratio is 4/5. But yeah, what I was saying is a lot of the, you want, at least at the beginning, a lot of the arithmetic to be very easy because you don't want people to miss trig questions, especially at the beginning, for something that has nothing to do with the trig, okay? And so, most of the things will be very easy computation. Even root 34 shouldn't be that difficult. You're adding 9 to 25. That shouldn't be taxing. And you should know that root 34 doesn't simplify, right? Because you should know its factorization is 2 and 17. Now, remember, I need to read my cosine ratio off of the original problem so that I don't accidentally read it falsely off of my triangle. This right here is theta, or it could be theta prime, whatever. And my sine ratio is -3/5 because that's opposite over hypotenuse. The cosecant is hypotenuse over opposite, sine's reciprocal. My tangent is -3/4, and my cotangent is -4/3, and that should be it. Okay. I'm hoping that you know, after we've gone through 4.3 and 4.4, and you've done the homework on 4.4, and we're also going through these several tests, that ought to be pretty straightforward. Let's go ahead and take a look at secant theta. Secant theta is equal to 4. Now we know that secant is the reciprocal of cosine. And we know on the unit circle that cosine is positive. We talked about this just in the last question. Cosine is positive in the first and the fourth quadrant. So if cosine's positive in quadrants 1 and 4, so is secant. Okay, so this is 1 or 4. Okay, now we need to determine whether we're in first or fourth quadrant. That is why we have cosecant theta is less than 0. Well, cosecant is, of course, the reciprocal of sine. So cosecant is negative where sine is negative, and sine is negative in the third and fourth quadrant. So obviously, what they have in common is that fourth quadrant. Now remember, you're looking at secant theta is equal to 4, and you're like, yeah, but I need a ratio. Well, that is a ratio. It's a ratio of 4 over 1. Okay? And I'm not going to draw this to scale. But basically, you just need to basically shoot a ray down here, make it into a triangle as sort of a placeholder for basically putting some of these values. Now, secant of 4. Now remember that cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And if that's the case, that squared is 16, that squared is 1, the difference of which is root 15, or the difference of which is 15, and of course take the square root to find that side using the Pythagorean theorem. Okay, now obviously not to scale because that's 4, that's just shy of 4, and that's 1. So actually it should be, you know, much steeper right here, a much more vertical ray. But like I said, I'm not going to do it to scale, I just want some place where I can put the numbers. Now, secant, we read it off of the question stem, the problem up here, and cosine is its reciprocal. Now, remember that this is not actually root 15. We're down in the fourth quadrant, so that needs to be negative right there. So when I take the sine, I have negative root 15 over 4, and this is -4 over root 15. I have a little more room right here than I did trying to squeeze in here, so I can go ahead and rationalize that denominator for you. Now tangent is going to be -root 15 because it's going to be the opposite over the adjacent. This right over here is -1 over root 15 or -root 15 over 15. And that's basically it, okay? You know, that's, and here's the thing, like the quiz that I have posted for you is of the same variety as a lot of what I've already shown you. It's not very long. A lot of it is just simple reading values off of a triangle, conversion of radians to degrees, degrees to radians, coterminal angles, all that sort of fun stuff. It's not meant to punish you. It's meant basically to assess whether, and I usually refer to these sections as rudimentary trig or elementary trig, because this really is just getting the foundations down before we move on into more difficult trigonometric operations and concepts. If you're waiting for things to get difficult, you don't have to wait very long. If you're expecting this to be difficult, you're overthinking it, okay? So let me go ahead and call it quits for this video number 2. Be looking for video number 3. It will be a third test that I gave the year after this one. And then I'll be looking at the team's chat to see if there are any questions coming my way based upon these videos. Bye.